Welcome to my video series on signals and systems. This is the first video in the series. Today we'll be looking at representing signals in a vector space. Let me get the title up there. There we go. Well, why do we do this? Because the reason is that signals that exist in some space X can be really difficult to define or even to represent and understand. So first of all, we look at them in some space that we can understand, like, for example, a vector space. So let's define such a vector space. First of all, we have a vector u that's in the space X. And this space X is a linear vector space, which means that it's a linear collection of vectors that can be both complex and real, with two operations, vector addition and scalar multiplication. So if we have if the vector u is made up of two points, u sub x in the x direction and u sub y in the y direction, then we can say that vector is the same vector in the v and w axes, u sub v in the v direction and u sub w in the w direction. Let's draw something. Let's draw a graph, because it's much easier to understand a graph, to represent what we mean here. So first of all, let's just remove this. And draw the graph. First of all, this is the graph of the vector u on the x and y axes, represented on the x and y axes. And these are the v and w axes, and that's how the vector u would be represented in the v and w axes.